All right, here's our second page now of our notes. We have just a couple more problems to do. One of them is a word problem here. So if you want to go ahead and read that along with me. Anastasia celebrated her 15th birthday with her family at her home in Mestre, Greece. 9 people, including Anastasia, live in her home. In honor of her birthday, they ate pound cake for dessert. Each kid ate 1 piece of cake, and each adult ate 3 pieces of cake. Altogether, 21 pieces of cake were eaten. How many kids and how many adults lived in Anastasia's house? All right, so if we take a look at this, you'll notice that we have 2 variables. The first variable is the number of kids. In other words, there are some different number of kids in there, and we're not quite sure at this point how many there are. And we also have a certain number of adults. Again, there's a certain number of adults. We're not exactly sure how many there are, but we have some other pieces of information that are going to help us figure out these 2 variables. And so one of the things that is talked about up here is the number of people that live in her house, her home. 9 people, including Anastasia, live in her home. So the number of kids and the number of adults together is a total of 9. So our first equation is x plus y equals 9. Kids plus adults equals 9. And then the other one is related to the cake that is consumed. We know that each kid ate 1 piece of cake, and each adult ate 3 pieces of cake. So 1 piece of cake per kid plus 3 pieces of cake per adult. Those adults must have been very hungry or have a sweet tooth, because 3 pieces of cake is a lot of cake for 1 person. But in any case, in total, they all ate 21 pieces of cake. All right? So now what we're going to do is we're going to solve this system and figure out how many kids and how many adults were there, and we're going to do that with that elimination method. And so to find the value of one of our variables, we are going to eliminate the other variable. This time, though, instead of adding the equations together, we're going to subtract the equations. So notice what happens. I'm just going to rewrite the 2 equations. So x plus y equals 9. And then basically we have another 1x. So I'm just going to write x plus 3y equals 21. So when we go ahead and subtract these equations, I'm going to put a little subtraction sign all the way through here. We subtract these 2 equations. Notice that the x's are eliminated. X minus x is 0. If we had tried to add these equations together, that would not have eliminated the x's. We'd have x plus x, which would be 2x. Since they are the same sign, both positive, if we subtract them, that's how we get the elimination done. So this time we're going to subtract. So 1y minus 3y will give us a negative 2y, and 9 minus 21 would give us a negative 12. So notice that when we did that, the x variable is completely eliminated. So now we can solve for the y. And we're basically there, right? We got negative 2y equals negative 12. So now, if we just divide by negative 2, we will get y is equal to positive 6. So that's half of our solution. Recall that our final solution is going to be the intersection of the 2 lines, so it's going to be an x and a y. And so now we're going to have to substitute that in, just like we talked about on the first side, into one of the equations, whichever one you think is easier. Now in this case, I definitely think that first one is easier. If we look at these 2 equations here and here, this equation up here looks to be a pretty easy. In fact, we can almost do this in our head, right? X plus y equals 9. So if y is 6, what does x have to be? In other words, if x plus 6 is equal to 9, then x has to be 3. So what did we just figure out? Well, let's go back to the beginning of the problem. What did x stand for again? X stood for the number of kids. So we just figured out here that there are 3 kids in the family. And what did Y stand for? Y stood for adults. There are 6 adults in the family. So we kind of solved that puzzle right there, that word problem up above, by using a system of equations. And those 2 equations will intersect each other at 3, 6, which in this case just means that this family has 3 kids and 6 adults. So we go ahead and subtract the 2 equations when they have the same, when the coefficients have the same sign. Notice down here, the y's have those same coefficients and they're the same sign, they're both negatives. So that's when we go ahead and subtract the equations together. Where on the front side, to solve it, we looked for the 2 equations. Again, they had the same coefficient, but when they were plus and minus, when they're opposite in sign, then that's when we added the equations together to eliminate the variable. So I'm not going to solve this very last one here on the back side, but what I do want you to write down is that when the coefficients have the same sign, they're both positive or both negative, we subtract the equations together. All right? So like right here, you can make a little arrow, we subtract the equations. So when they're like negative, negative, or if they're positive, positive, we subtract the equations together. Right? When the coefficients have opposite signs, we add the equations together. So when one is like positive, negative, or when we have a negative and a positive. So like positive 9x and negative 9x. Then we would add the equations together. If we had a negative 5x and a positive 5x, then we would add the equations together because that would eliminate this to 0, eliminate it to 0. So that's the general rule of thumb.